Core concerns for electrical safety when dealing with systems operating at 600 volts and under are of paramount importance. Firstly, always work dead. This means de-energizing equipment before commencing any work. To ensure the power is off, use appropriate testing devices such as a voltage meter or insulation tester to verify the absence of voltage. Secondly, utilize ground fault circuit interrupters, often abbreviated as GFCIs. Install GFCIs on all circuits where feasible, particularly in areas near water sources or damp locations. Regularly test GFCIs to ensure they are functioning correctly and providing the intended protection. Thirdly, personal protective equipment, or PPE, is crucial. Wear insulated rubber gloves, safety glasses, and appropriate protective clothing whenever working on electrical equipment. Use proper insulated tools and extenders to maintain a safe distance and prevent accidental contact. Fourthly, implement lockout/tagout, referred to as LOTO, procedures. Follow established LOTO procedures diligently to prevent the accidental energization of equipment while work is in progress. Employ multiple layers of protection, such as lockout devices and tags, to ensure equipment remains de-energized. Fifthly, focus on hazard identification and assessment. Conduct thorough inspections to identify potential hazards, including loose connections, frayed wires, and overloaded circuits. Assess the risks associated with these hazards and implement appropriate mitigation measures to reduce or eliminate them. Sixthly, conduct regular electrical inspections. Have electrical systems inspected regularly by a qualified electrician to identify and correct any deficiencies or potential safety issues. Follow established inspection criteria and standards to ensure a comprehensive assessment. Seventhly, implement a robust electrical maintenance program. Perform routine maintenance tasks such as tightening connections, cleaning contacts, and lubricating moving parts to keep electrical equipment in good operating condition and prevent failures or hazards. Eighthly, provide comprehensive education and training. Provide regular training to employees on electrical safety practices, covering topics such as hazard recognition, safe work procedures, and emergency response. Emphasize the importance of proper procedures and the consequences of non-compliance. Ninthly, establish emergency preparedness plans. Develop emergency response plans for electrical accidents, including fire, shock, and arc flash incidents. Train employees on how to respond to such emergencies, including how to summon help and administer first aid. Tenthly, ensure code compliance. Adhere to applicable electrical codes and standards such as the National Electrical Code to ensure safe electrical installations and practices. The NEC provides detailed requirements for electrical systems covering topics such as wiring methods, overcurrent protection, and grounding. To elaborate further on working dead, remember that simply turning off a switch is insufficient. Electrical circuits can store energy in capacitors, and even after disconnection there may still be a hazardous voltage present. Therefore, always use a voltage meter to verify that the circuit is de-energized before touching any components. Look for a voltage meter that is rated for the voltage levels you are working with, and follow the manufacturer's instructions carefully. Regarding ground fault circuit interrupters, these devices are designed to protect against electrical shock by detecting small imbalances in the current flowing through a circuit. If a ground fault is detected, the GFCI will quickly trip the circuit, interrupting the flow of electricity and preventing a potentially fatal shock. GFCIs are particularly important in areas where water is present, as water can significantly increase the risk of electrical shock. When it comes to personal protective equipment, ensure that the insulated rubber gloves you are using are rated for the voltage levels you are working with. Inspect the gloves for any signs of damage, such as cracks or punctures, before each use. Safety glasses or a face shield should always be worn to protect your eyes from arc flash and other hazards. Protective clothing, such as flame-resistant shirts and pants, can help to minimize burn injuries in the event of an electrical incident. Regarding lockout/tagout procedures, these are designed to prevent the accidental energization of equipment during maintenance or repair work. The basic principle of LOTO is to isolate the equipment from its energy source and then attach a lock and tag to the energy isolating device. The lock prevents the device from being turned on, and the tag provides information about why the equipment is locked out and who is authorized to remove the lock. When conducting hazard identification and assessment, be aware of common electrical hazards such as exposed wiring, damaged insulation, and overloaded circuits. Look for signs of overheating, such as discoloration or melting of components. Use appropriate tools and equipment to inspect electrical systems, and never take shortcuts or bypass safety procedures. When performing electrical maintenance, always disconnect the power before working on any equipment. Use insulated tools to prevent accidental contact with live circuits. Tighten all connections to ensure good electrical contact. Clean contacts with a suitable solvent to remove any dirt or corrosion. Lubricate moving parts to prevent wear and tear. Education and training should cover a wide range of topics, including electrical safety regulations, hazard recognition, safe work practices, and emergency procedures. Employees should be trained on how to use electrical testing equipment, how to select and use appropriate PPE, and how to perform LOTO procedures. Training should be provided regularly and updated as needed to reflect changes in technology and regulations. Emergency preparedness plans should include procedures for responding to electrical fires, electrical shock incidents, and arc flash events. Employees should be trained on how to use fire extinguishers, how to administer first aid to victims of electrical shock, and how to evacuate the area in the event of an arc flash. The plan should also include procedures for contacting emergency services and reporting the incident. Adhering to applicable electrical codes and standards is essential for ensuring the safety of electrical systems. The National Electrical Code, or NEC, is a widely adopted standard that provides detailed requirements for electrical installations. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. By following the requirements of the NEC, you can help to ensure that electrical systems are installed and maintained safely. In addition to these core concerns, there are several other factors that can contribute to electrical safety. Firstly, ensure that all electrical equipment is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock. Secondly, use surge protectors to protect sensitive electronic equipment from voltage spikes. Surge protectors can help to prevent damage to computers, televisions, and other electronic devices. Thirdly, never overload electrical circuits. Overloading a circuit can cause the wires to overheat, which can lead to a fire. Fourthly, be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can occur where short circuit occurs. Arc flash can cause severe burns, blindness, and even death. Finally, if you are not qualified to work on electrical equipment, hire a qualified electrician to do the work. Electrical work can be dangerous, and it is important to have the right training and experience to do the job safely. Remember that electricity can be dangerous, and it is important to take precautions to protect yourself and others from electrical hazards. By following these core concerns and taking other safety measures, you can help to create a safe working environment. Consider the specific environment that is present and tailor the safety practices to consider it. For example, wet locations require additional care and precautions. Furthermore, when selecting testing equipment, ensure it is appropriate for the task and voltage level. Calibrate the equipment regularly to ensure accuracy. Also, consider the use of non-contact voltage testers as an initial assessment tool, but never rely solely on them. Always verify with a contact-based meter after initial assessment. When it comes to GFCIs, understand that they are designed to protect people, not equipment. While they can help prevent equipment damage in some cases, their primary purpose is to prevent electrical shock. Different types of GFCIs are available for different applications. Select the appropriate type for the specific installation. Also, remember that GFCIs need to be accessible for testing and maintenance. Do not install them in locations where they are difficult to reach. For PPE, regularly inspect all PPE for damage or wear. Replace any damaged or worn PPE immediately. Ensure that employees are properly trained on how to use and maintain their PPE. Also, be aware of the limitations of PPE. It is not a substitute for safe work practices. Regarding LOTO, a procedure should be specific to the equipment being worked on. Develop detailed LOTO procedures for each piece of equipment that requires maintenance or repair. The procedures should identify all energy sources that need to be isolated. The LOTO devices should be standardized to avoid confusion. Also, ensure that all employees are trained on the LOTO procedures and that they understand their responsibilities. When performing hazard identification and assessment, involve employees in the process. Employees who work with the equipment on a regular basis are often the best source of information about potential hazards. Use a checklist to ensure that all potential hazards are identified. Document all hazards and the mitigation measures that are implemented. Also, regularly review the hazard assessments to ensure that they are still accurate and up to date. For electrical inspections, use a qualified electrician to perform the inspections. The electrician should be familiar with the applicable electrical codes and standards. The inspection should cover all aspects of the electrical system, including wiring, equipment, and grounding. The electrician should provide a written report of the inspection findings. Correct any deficiencies that are identified during the inspection. When performing electrical maintenance, use the proper tools and equipment for the job. Never use damaged or worn tools. Follow the manufacturer's instructions when performing maintenance tasks. Also, keep a record of all maintenance that is performed. Education and training should be ongoing. Provide refresher training on a regular basis to reinforce safe work practices. The training should be interactive and engaging. Use real-world examples to illustrate the importance of electrical safety. Also, encourage employees to ask questions and provide feedback. Emergency preparedness plans should be practiced regularly. Conduct drills to ensure that employees know what to do in the event of an emergency. The plan should be reviewed and updated on a regular basis. Also, make sure that all employees know where to find the emergency contact information. Code compliance is an ongoing process. Stay up to date on the latest electrical codes and standards. Use a qualified electrician to perform all electrical work. Also, obtain all necessary permits before starting any electrical work. By following these additional tips, you can further enhance electrical safety in the workplace. Remember that electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical accidents. Lastly, do not underestimate the importance of clear communication. Ensure that all employees are aware of the potential hazards associated with electrical work and the safety precautions that must be taken. Use signage to warn of electrical hazards. Conduct safety meetings to discuss electrical safety topics. Encourage employees to report any electrical hazards that they identify. Effective communication is essential for creating a culture of safety. Also, consider the use of technology to improve electrical safety. For example, use thermal imaging cameras to identify hotspots in electrical equipment. Use drones to inspect electrical infrastructure. Use software to manage LOTO procedures. Technology can help to make electrical work safer and more efficient. By embracing technology and continuing to prioritize electrical safety, you can create a workplace that is free from electrical hazards. Remember that electrical safety is not just a matter of compliance, it is a matter of protecting people's lives.